Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Aromatic stabilization and conjugation provide maximum thermodynamic stability to organic molecules. Among polycyclic systems, a fully aromatic ring, benzene-like, is far more stable than a non-aromatic or partially conjugated system due to delocalization energy. Moving on to the next step. Examine the degree of unsaturation and conjugation in each option. Option A has a conjugated diene system in the B ring region with a non-aromatic A ring bearing the ACO group. The double bonds are not forming a fully aromatic ring. Option B has a single double bond in ring A, enol acetate type, with no extended conjugation into ring B, least conjugated of the four. Option C has a 1,3 diene system in ring A with ACO and conjugation extending into ring B, but ring A is not fully aromatic, it is a cyclohexadiene, not benzene. Option D has a fully aromatic ring A, phenol acetate is equal to ACO on a benzene ring with extended conjugation into ring B, forming a naphthalene-like bicyclic aromatic system, rings A and B together, with C9H19 at C17. Moving on to the next step. Apply aromaticity criterion. A fully aromatic ring, 6 pi electrons, Huckel rule, as in option D, provides tilde 36 Huckel mole of extra stabilization, resonance energy, compared to a non-aromatic cyclohexadiene. The ACO group on a benzene ring, phenol acetate, in option D means ring A is fully aromatic. And for the final step, compare options. Option D has the aromatic A ring, benzene ring with ACO, plus conjugation extending into ring B, giving maximum stabilization. Option C has a cyclohexadiene, not fully aromatic, in ring A. Options A and B have even less conjugation. Why other options fail? A non-aromatic diene system, less stable than aromatic. B only one double bond in ring A, minimal conjugation, least stable. C cyclohexadiene ring A is not aromatic, it lacks the full 6 pi aromatic stabilization. D fully aromatic ring A with extended conjugation and longest alkyl chain, C9H19, thermodynamically most stable due to aromaticity. Therefore, the correct answer is D. Therefore, the correct answer is option D.